Hello, Mrs. Middleton here to go over one of the coolest power sources, nuclear power. If you took chemistry, you might know this stuff already, but if you fell asleep during that class, or you need a refresher, here it comes at you. Nuclear power is generated through fission, where atoms of uranium-235, which is stored in a fuel rod, are split into smaller parts after being struck by a neutron. Nuclear fission releases a large amount of heat, which is used to generate steam, which powers a turbine and generates electricity. What we are seeing in this first image is how energy is created through fission. You have an unstable atom, you shoot a neutron at it, and it starts the decaying process. As decay happens and the bigger unstable atom becomes smaller, energy is released. Radioactivity occurs when the nucleus of a radioactive isotope or unstable atom loses energy by emitting radiation. Within the nuclear power plant, fission occurs in the containment structure. Little pellets of radioactive uranium-235 are stored in the fuel rods, which are found at the control rods in the diagram you are looking at. Here the control rods are dipped in cold water to slow the process of fission. When the reaction needs to be happening faster, the control rods are taken up and out of the cold water. As fission occurs, it warms the water, which is pumped to the steam generator. Just like any other power plant, steam is created and turns a turbine, which creates electricity. The steam that turned the turbine is now moving to the cooling towers, where it condenses back into water. Notice that the water that is creating the steam is in a different system than the water coolant mixture that comes in contact with the control rods. The water coming from a nuclear power plant is not radioactive. In fact, you receive more radioactivity living next to a coal power plant than a nuclear power plant because there are more regulations and restrictions for a nuclear power plant. In the past, the only nuclear reactor meltdowns or partial meltdowns have occurred due to human error. Chernobyl was a result of scientists testing a safety mechanism and interfering with its typical and expected response. And 3 Mile Island had, again, human interfering with the safety mechanisms, which would have fixed the problem. The only meltdown we have experienced that wasn't created by humans was in Fukushima in the spring of 2011. This was created by an earthquake. The reaction was initially shut down, but because of a power outage, the backup generators started the reaction again. A tsunami then came into play, flooding the lower levels of the reactor and knocking out the backup generators. But at that time, the damage had already been set into motion. Again, this is not normal for a nuclear power plant. It has its own safety precautions. One of the main problems with uranium-235 as a fuel source is that uranium continues to be radioactive for hundreds of years. There is no great place to put the waste. Compared to coal, nuclear creates much less waste. Here's some images of the steps taken in containment after the reaction has happened. So they have these cooling pools, and then the final stage is right here where they are in a special containment area being monitored all the time. Nuclear power generation is a non-renewable energy source. Nuclear power is considered a cleaner energy source because it does not produce air pollutants, but it does release thermal pollution and hazardous solid waste. This is an image of 3 Mile Island, which is decommissioned. That's all the main points on nuclear power. Have a great night.